right, so three things. We'll go with three things that I want to get done today. Thing number one is we've got some notes to talk about today. Thing number two is I've got some things to hand back to you today. And thing number three is I want to stamp and give you time to work on your homework. The door is open, Cam. Just gotta turn the knob and push.
Cam, it's open.
Turn the knob and push. In that order. Okay. Okay. So if you wanted to get started, there are some retrieval questions that are available for you. One graph, one give me another coordinate, and one graph, so a second graph of the system of equations. Okay. So if you wanted to do those retrievals right now. Y equals negative 2x plus 7. Talk to me about that line.
Decreasing.
Okay, so it's decreasing. So as we're going to the right, it's going down. Okay, what else?
And then the y-intercept of 7.
So give me a direction and a number.
So, 0 up the right and then up 7.
So up 7 from the origin and put a dot. 1 and 2, 3 and 4, 5 and 6 and 7. Put a dot. Okay? What else do we know about it?
Slope is negative 2.
Two directions, two numbers.
Down 2 and right 1.
Down 2 and right 1. Rinse, lather, and repeat.
Yes.
What if I didn't want to go down and right?
Then you can go up and left.
Up how many?
2.
Up 2 and left 1. Okay? Then we got to draw in our line. Utilizing something straight edge, ID, ruler, etc. Okay. Alright. So there's the equation of the line y equals negative 2x plus 7. Then it's asking if the point 2, comma 7 is on it. 2 would be right 2 and up 7. 1, 2, 3, 5, 6, and 7. So here is the point 2, comma 7. Is that on our line? No, that is not. Okay? So it is not an equation or not a solution to our line. Question number 2 then asks to give us a coordinate that is a solution. Well, we found one right off the start. We said that 0, comma 7 was a point that made it a solution because it's a point that is on our line. Give me another one. 1, comma 5 would also work. Give me another one.
2, comma 3.
2, comma 3 would also work.
3, comma 1.
3, comma 1. 4, comma negative 1.
5, comma negative 3.
5, comma negative 3. All of those, etc., all make the solution work. Or all make the equation work, I should say. Okay? Then it went on to number 3, and it said graph the system of equations and find the point where they intersect. Verify that intersection is a solution to both equations. So we'll take the first one first.
Me and Anna can do this one.
Okay, talk to me.
Oh. Okay, so the y-intercept is 6, so put 1 there. And then the slope is negative 3, so go down 3 and right 1. Again. And again. And then you can make that a line if you would like to.
What if I didn't want to go down and right?
Then you can go up 3 and left 1. And then make that a line. Or a different color. I don't know what you're doing.
Okay.
And now, the other one, the y-intercept is -9, so put a dot on the y-axis
Anywhere or just at -9?
at -9.
Okay.
And then slope is 2, so you go up 2 and right 1. Or you can go down 2 and left 1.
Do those lines intersect?
Yes.
Yes, they do. Where do they intersect?
3, -3.
3, -3, I would also agree with. Okay. How do we verify that that is the solution?
You plug it in.
Where?
To the equation. To the y.
Where?
To the bottom equation.
Just the bottom one?
Both equations.
To both. It's got to work in both equations in order for it to work. So if I plug that into the blue equation, I would have -3 equals -3 times 3 plus 6. -3 times 3 is -9. -9 plus 6 is -3. So -3 is equal to -3. It works into that one. Then I got to plug it into the bottom equation, the pink equation. -3 is equal to 2 times 3 minus 9. 2 times 3 is 6. 6 minus 9 is -3. And -3 is equal to -3. This, ladies and gentlemen, is the verify portion. And so if it asks you to show that, you have to show that.
Okay.
Most of the time we do that in our head. Yes. No. So mean.
Wait, can I at least write on the paper?
I don't think questions are the best. Because they're all multiple choice.
Well, yeah, but I don't know. I feel like it
I don't know. Let's not worry about that. 'Cause it's not even finals
How
time
many
yet.
questions?
But it is.
How many questions?
Oh, we worry about that when it's finals time.
But I'm already
31.
That's great.
It's 30.
Okay. All right. So let's talk about Carlos and Clarita making a list of some of the issues they need to consider as part of their business plan to care for cats and dogs while their owners are on vacation. So the first thing that they're going to have to worry about is they're going to have to worry about space for it to fit. Okay? So cat pens require 6 square feet of space, while dogs require 24 square feet. Okay? Carlos and Clarita have up to 360 square feet available in the storage shed for their pens and their runs, while still leaving enough room to move around the cages. So they have 360 square feet. Okay? So we should probably figure out some variables here. So let's say X here is the number of what? Dogs or cats?
dogs.
Dogs first. Okay. And then we'll say Y is the number of cats. Okay. So based off of that, with X being the number of dogs and Y being the number of cats, make an equation, a spatial equation for us. How much space does a dog need? 24. So how much space does 2 dogs need? 48. 3 dogs? 72. Okay. Yep. Okay. And so on and so forth. X dogs. How much space does X dogs need? Yes, we do.
24 dogs.
Just 24? What do you got? It's 24X. What?
You're like, saying it in a twister.
Okay. How much space does a cat need?
6Y.
So So 6y for y amount of cats would be 6y.
Yeah.
We're going to add that, we're going to subtract that, we're going to multiply that, we're going to divide that.
Add.
Add that. And how much space do we have to use? 360. So there is our equation for that. Okay. Startup costs. Carlos and Clarita plan to invest much of the $1,280 they earned from their last business venture to purchase cat pens and dog runs. Okay? It will cost $32 for each cat pen and $80 for each dog run. So how much, or so make me an equation out of that one.
Can we use the same variables or not?
We're still using X for dogs and Y for cats, yes.
So 32 y plus 80 x equals 1,280.
Could I go 80X plus 32Y equals 1,280?
Yeah.
Because then it's in the same order. Does that work? Okay. All right. Of course, Carlos and Clarita want to make as much money as possible from their business, so they're trying to determine how many of each type of pets they should plan to accommodate for. They plan to charge $8 a day for boarding each cat and $20 a day for each dog. Okay. All right. So that's good to know. Okay. 8 per cat, 20 for each dog. Okay. They are confident that they can keep all of their boarding spaces filled for the summer. Turn the page. Okay. So the question is, what type of, or how many of each type of pet should they prepare for? Okay. Oh, it's at the bottom? Oh, sorry. Unturn the page then. Okay. So I would draw this chart in. Okay. Clarita's and Carlos's dad says that they should think of 12 of each. Okay, so 12 cats and 12 dogs. Same amount. Okay? So we said on the last slide, we said that cats was Y, correct?
Correct.
We said dogs was X, correct? We said square feet used was, nope, what was our equation? 24x plus 6y. Okay. Now they can only have up to 360 square feet, though, right? But that's how much space that they need for each one. Okay. Money spent. How much did we figure, or what did we figure out for the money spent? Wasn't that 80x plus 32y? Yes?
Yeah.
Okay. And then the money earned per day, we should add the per day in here. What did they say? They were going to make $8 for a cat and $20 for a dog. Okay. So then that one would be 20x plus 8y. Right? Okay? So if we follow their dad's rationale, how much square feet would they use? If we follow their dad's rationale, we would use 360. I would concur that they would use 360 square feet. Do you agree?
Yes.
Okay. Okay? How much money would they have to spend to house 12 cats and 12 dogs?
$1,344. Or no.
How much? Yes? Okay. How much money would they make? $336 a day? Okay. With me?
Yeah.
Okay. Let's come up with another number. Well, first off, hold on. Let's ask the question. Does it work for square feet?
Yes. Yeah.
Because we had 360 square feet to use. Yep, so that one works in terms of square feet. Does it work in terms of money spent? No, it doesn't, right? Because they only have 1,280 to spend. Yes? Okay. All right, so it doesn't work there. And money earned, so they would be earning $336 a day. Okay? Let's come up with a different one now. Give me a number of cats and a number of dogs.
8 cats and 10 dogs.
Okay. You calculate the amount of square feet used, the amount of money spent, and the amount of money earned. Go. I got that they used 288 square feet. Do we agree with that?
Yeah.
Yes. I got that they made they had to spend $1,056, but then I get that they only make $264 a day. Yes? Okay. Let's come up with a different one. Ty, how many cats? 10? Okay. Kelvin, how many dogs?
13.
Calculate it. Square feet used, anybody? 372. Money spent, anybody?
1,360.
Money earned. Do any of those, so both of these up here worked, right? Does that one work? 10 cats, 13 dogs.
No.
Where doesn't it work?
The square feet used.
The square feet used, it doesn't work.
The money spent.
And the money spent, it doesn't work, right? Okay. So,
I'm gonna do another one.
you want to do another one? Okay, which one?
10 cats and 11 dogs.
And 11 dogs? Okay, calculate it. Go. I got 324 square feet used. Oops, I shouldn't use red. I got 324 square feet used. I got $1,200 that they had to spend, and I got that they made $300 a day. Does that work out in terms of square feet?
Yeah.
Yes. Does that work out in terms of money spent? Yep. Okay. All right. So there needs to be some constraints on some of them. Okay? Meaning square feet used needs to be less than 360, correct? So we're going to tweak that equation. That equation again was 24x plus 6y. And instead of putting it equal to 360, we're going to say that needs to be less than or equal to 360. Because we have a certain amount of space that we can use, and we can't go beyond that. Okay? So that one's going to be tweaked. Money spent, that was 80x plus 32y, correct? That needed to be less than or equal to 1,280. So we need to make some changes to our equations. We can make them inequalities, and then we can find a range of things that work. Then what they would do then is plug one that has like the biggest, you know what I mean? Like you want to have more dogs, right? Because you want to have more money. So the more dogs you have, the more money you make every day. You're making over twice as much on a dog than you are a cat. And so you want to have more dogs. So you find where you have the biggest dogs or the most dogs that you could use or that you could board, and then the amount of cats. Okay? Challenging arms today. Okay, both constraints considered simultaneously, because then what we're going to get into right after semester break is we're going to get into graphing those inequalities, and then they're going to give us a region that we'd have all of the things that we would want it to be in that region. Okay? All right? We did all of that symbolically, all that good stuff. Yeah, we did page 10 already. Yep, that's good. In pet sitters, the statement about startup costs and space are controlled by constraints because of limitations. I mean, really, it's limitations. Limits on space and money. Okay. Viable options for the space constraint include anything less than, so that would have been that one that we had. What was space? 6, that was the 6y, right?
Yeah.
24x? 24x? Okay. Because there's only 360 square feet to use. So it's got to be less than or equal to that. Considers context being model linear system equation. We talked about that. Carlos, we want to maximize their profit. The minimum profit is not a constraint because it's based off of based off the money and the space equations. So instead, the profit is a result of however many pets they have. Okay? Handle? All right, let's take a peek at your homework tonight. I'll come back to this slide after we take a peek at the homework. Okay? That's last night's, that's last night's. Here we go. So it looks like we are graphing, solving by graphing on 4 of them. We can handle that. Looks like we have to make an equation. Okay. The kicker is they want to make here at least 2,000. So they want you to come up with 5 possible ticket combinations between children and adult tickets to make it work. Okay? For instance, adults cost $10. If you sold 201 adult tickets, it would work, correct? Because each ticket costs $10, so that would be $2,010. Okay, does that make that work? Yep, so there's one of them for you. 201 adult tickets. Okay? Because that's under 350 people. Okay? Utah Jazz scored 102 points. 3 points, 2 points, 1 point. 5 combination of baskets that would add up to be 101 points. Okay? So again, coming up with 5 different combos there. Tables, arithmetic sequences. Ooh, this is good because this is a good review for your final coming up. Arithmetic sequences. So that means we're adding to get the next term. Coming up with those, coming up with the equation. Looks like we've got some of those. Some thought-provoking questions there on those two, like that, and that's it. There we go. Nailed it. So you have the rest of the time now to work on